A white dwarf, the size of Earth, can weigh as much as our entire sun. A teaspoon of it would crush your hand under the weight of a mountain. But that is just the beginning of the strangest catalog in the universe, the catalog of stars that have already died. White dwarfs are what is left when a star like our sun runs out of fuel and sheds its outer layers into space. No fusion and no furnace, just a slowly cooling ember, made of matter so dense that a single cubic centimeter can weigh more than a car. Sirius B, the companion to the brightest star in our night sky, is a white dwarf packed into a sphere barely bigger than Earth, and it holds nearly as much mass as our sun. It will keep glowing faintly for billions of years, fading like a coal pulled from a fire. But not every dead star gets to fade quietly. Some of them ignite one final time. That ignition is called a nova. Take a white dwarf, place it close enough to a companion star, and let it siphon hydrogen off that neighbor's surface. The stolen gas piles up until it detonates in a burst of fusion, brightening the white dwarf thousands of times over in a matter of days. Unlike a star's death, this explosion does not destroy the white dwarf. It survives, and it can do this again and again, sometimes every few decades. But there is a version of this process that only happens once, and it is where things become far more violent. If a white dwarf pulls in too much mass, it crosses a threshold scientists call the Chandrasekhar limit, roughly 1.4 times the mass of our sun packed into a sphere the size of Earth. Cross that line, and the white dwarf does not just flare, it detonates completely. What follows is known as a Type 1, a supernova, an explosion so consistent in brightness that astronomers use it to measure the size of the universe itself. No remnant star is left behind. Just an expanding shell of hot gas and heavy elements scattering into the dark. And this is where things become strange, because this thermonuclear death is not the only way a star can be torn apart. There is another kind of collapse that happens to stars far larger than our sun. When a massive star, one with many times the mass of our sun, finally exhausts its fuel, its core collapses in less than a second. The outer layers rebound off that collapsing core in a shock wave, and the star tears itself apart in a core collapse supernova. For a few weeks, that single explosion can outshine an entire galaxy. But the star does not vanish completely. Something is always left behind at the center, and what that something becomes depends entirely on how much mass the core had to begin with. If the collapsing core lands in a certain mass range, gravity crushes its protons and electrons together into neutrons, and you get a neutron star. Picture an object with more mass than our sun squeezed into a sphere about 20 kilometers across, roughly the size of a city. A sugar cube-sized piece of it would weigh about as much as a mountain range on Earth. Some neutron stars spin hundreds of times per second, sweeping beams of radiation across space like a lighthouse, and we call these pulsars. The first one was identified in 1967 by Jocelyn Bell Burnell, and it was so precise and rhythmic that scientists briefly wondered if it was artificial. But some neutron stars are not just spinning. Some of them are magnetic in a way that should not be survivable. These are called magnetars, and they carry magnetic fields trillions of times stronger than Earth's. A magnetar close enough to you could, in theory, distort the atoms in your body simply by existing nearby, rearranging the electron clouds that hold your molecules together. SGR 1806-20, one of the most powerful magnetars known, released more energy in a fraction of a second than our sun produces in 100,000 years. If you have made it this far into the graveyard of dead stars, this is the moment to like this video, Because the next entries do not just bend matter, they start bending light itself. Because if the collapsing core is massive enough, neutrons cannot hold the line either. Gravity keeps winning, and the core keeps collapsing past any known state of matter until it forms a black hole, a region where gravity is strong enough that not even light can escape. Stellar mass black holes, like Cygnus zone, form from single collapsing stars and typically weigh somewhere around 10 to 20 times the mass of our Sun. No surface, no light, no way back out. Once you cross the boundary, called the event horizon, but somewhere out in the galaxy, there could be a black hole with no visible companion star, drifting silently through space, and we would have almost no way of detecting it until something passed too close. That silent kind is called a rogue black hole, and it is one of the most unsettling objects on this list precisely because it hides in plain sight. Unlike Cygnus zone, it has no glowing disk of stolen gas to give away its position, no companion star lighting it from the side. It simply exists, wandering the space between star systems. In 2022, astronomers announced the first strong candidate for an isolated black hole detected through its gravity alone, warping the light of a distant star as it passed in front of it. It offered no other sign it was there. And if something that massive can hide from every telescope we own, then the scale of what is still out there becomes almost impossible to comprehend. Because stellar mass black holes are not where this ladder ends. At the center of our galaxy sits Sagittarius A star, a black hole with about 4 million times the mass of our Sun, imaged for the first time in 2022. Compared to the black hole at the heart of galaxy M87, imaged in 2019, Sagittarius A star is almost gentle, like a lion sleeping quietly at the center of its territory. But somewhere out past our galaxy, there are dead star remnants that make even a supermassive black hole look modest, and they do not come from a single star at all. TON 618 is a black hole with an estimated mass of over 60 billion suns, a number so large it stops feeling like astronomy and starts feeling like philosophy. It likely did not form from one star collapsing, but from countless mergers over billions of years. Black holes, swallowing black holes, gas clouds, and entire stellar clusters, layer after layer compounding into something almost incomprehensible. If an object like this existed anywhere near our solar system, its gravity would have reshaped every planet's orbit long before we ever noticed the danger. But even TON 618 is theoretical compared to what physicists say could exist in the most extreme, unconfirmed corner of this catalog. That final entry is the naked singularity, a hypothetical point of infinite density with no event horizon hiding it, meaning the most extreme gravity in the universe would sit fully exposed, unshielded, visible to anything nearby. We have never confirmed one exists, and general relativity's own equations suggest nature usually prevents them, wrapping every singularity safely behind a horizon. But if one were ever found, it would mean the universe's own rules about hiding its most extreme secrets do not always hold. And that possibility alone keeps physicists testing the boundaries of the theory to this day. That is the full ladder, from a slowly cooling ember the size of Earth to a theoretical scar in the fabric of physics itself. Every one of these objects started as a star, and every one of them ended up rewriting what we thought matter and gravity were capable of. If this expanded how small you feel in this universe, drop a like and subscribe, because there are galaxies, dimensions, and hidden physics still waiting to be explained, and you are not ready to go back to normal space just yet.